to meet all of you. My name is Andrew. As Mike said, I am one of the solution engineers here at Lightstep, and I will be taking you folks through a bit about the integration between Nobl9 and Lightstep, as well as showing you some of the Lightstep capabilities and kind of where we fit into this ecosystem that we're all dealing with here. I will take about the next 30 minutes to actually go walk through this demo, and then I'll try to, I'll leave 10, 15 minutes or whatever time's necessary for questions and answers at the end of this. And if there are any other questions or follow-up and you're interested in learning more about Lightstep, feel free to email me at andrew@lightstep.com. Happy to answer any questions for you after this, okay? So for today's purposes, we're going to take you through a quick overview of some of the workflows and use cases that we handle here at Lightstep and how that really works for modern DevOps and SREs in the distributed world. I am not, there's folks that are on the line. I don't assume that you know anything about Lightstep and the product and what we do. So I will show one slide that really just kind of talks through the architecture of Lightstep. So at a very high level, what is Lightstep, at least the product and the company? So we are one of the founders of, if you're familiar with OpenTelemetry and open tracing, these are open source projects that are part of the CNCF. They're actually the second most, I think, participated projects after Kubernetes in the CNCF. And the whole idea is that with modern distributed software architectures, really trying to find problems, understanding root cause when problems happened, because becomes much more difficult than the days of old monolithic, big Java.NET apps, right? Back in the old days when there was some problem with your code, you basically just go look at either your APM tool or your logs for that particular app, and you pretty much find the answers to it. But now with distributed systems and microservices, Kubernetes, all of those buzz phrases nowadays, what's happening is that when you have a problem, if you see something that's wrong on your website or something slow on your mobile browser, it's very difficult to know, which of the 50 downstream services that this request hits, where that problem is coming from. So what we do at Lightstep is we leverage both kind of metric data, right? So your infrastructure metric data sources, as well as distributed tracing information to help you understand the performance of your systems. And if people are not familiar with distributed tracing, at the very basic level, what it is the ability to follow any given request through your service boundaries at the code level, at the application code level, to understand the timings of a particular request, what services and operations they're spending their times in, what are the attributes of these requests, where the errors and latencies, reside. So that's kind of what we do. We as a Lightstep, as a company, we accept that data format and we help analyze that data in order to help you as our customer understand when you have problems, when do you have problems, and then when you have problems, how do we quickly identify what the causes are and why they happened, okay? So Lightstep naturally fits very well together with Nobl9 because Nobl9 actually can use our metrics and data sources to help actually monitor your systems for the SLOs and your error budgets, so you understand when problems are kind of rising and approaching. And Lightstep is the data source that generates those metrics for Nobl9, as well as the source for you to go and actually, when you find that there is a problem, when you've exceeded your error budget, the source to go and try to investigate why that is happening. Okay, so like I said, I have one slide to show the group here. In this slide, this is just a high-level architecture of Lightstep, right? In this case, this particular system, is our SaaS system. In black, it's Lightstep. We are in the cloud. The only thing I really wanted to point out here is the way that Lightstep works is that your code that that is instrumented for both distributed tracing and metrics is instrumented in a completely open source manner. You don't actually, there's no such thing as a Lightstep agent or Lightstep, SDK. You basically drop in this open source instrumentation and we accept that data source and are able to actually analyze 100% of the requests that goes through your system. So we actually capture everything without any sampling, and we're able to actually analyze that entire data set for you, as well as allow you to query for anything in that data set, at least for the last hour. And so it's very powerful in terms of understanding how the data works. But what happens is that your services generate both these distributed tracing data sets and time series data sets, and they send it to Lightstep using this open source mechanism, and we analyze that for you. Okay, so with the way that Lightstep works, then I'm going to actually jump into Nobl9 as kind of the beginning step here. Okay, so you may or may not be familiar with this particular screen, but this is just a simple kind of SLO monitor screen. But one of the things that happened very recently is Nobl9 obviously has many kind of certain set of integration from different data sources. We are one of the newest data sources that can feed data into Nobl9. As you can see, if I come in here to add a new data source, Lightstep is now listed in here. And if I select Lightstep and using the agent approach, the only thing that you really have to set up is there's going to be a few kind of Lightstep parameters, what project, what account you have in Lightstep. And then the system will automatically connect to Lightstep and start, letting you configure your data sources and pulling data in. So for today's purposes, of course, we've already created a data source for Lightstep, right? And within this data source, what we've already done is set up monitoring for certain SLOs and SLO objectives. So we took two of our services within our demo environment and have fed data into Nobl9. And the way that this works is within Lightstep, and I'll kind of point to that a little bit later, there's a method that we can use to calculate or generate your service level indicators, right? So in this case, it could literally be anything that runs through your system. You could actually configure Lightstep to say, I want to watch the performance of this one operation that is from this one service, but I only want to watch it for this one region of the country or this one user. It doesn't matter for Lightstep. We can generate metrics based on these kind of indicators for anything in the system, and that can then be fed into Nobl9, where you can then set up, obviously, the different service level monitoring rules, and you can be able to tell when your error rates are burning down and things like that. And all of that is fed from a query that runs from Lightstep, and all the data that's feeding this comes from Lightstep. So for today's demonstration purposes, what we're looking at is we have this SLO that we've set up for an iOS device. So we have the ability in Lightstep to monitor, anything from your backend services to your serverless functions and mobile devices and web browsers, anything that basically runs code. And so the whole idea here then is in this situation, obviously this is demo data where we periodically manufacture some regressions. What we've set up is for one of our services, the mobile device, there is an operation called update inventory. This demo app that we use is a dummy e-commerce app. And so what we have set up is this for this inventory update operation, we're monitoring that to help understand the user experience, because we know that, obviously, if my customer cannot update their inventory on their web store through our app, then they're going to have a poor experience with our system. So therefore, we're using this as kind of the indicator for calculating the SLO. So what we see here is obviously the performance is beginning to spike, your reliability burn down, and your error budgets and all that is moving because of this regression that's happening. So the whole idea now is, okay, now we know there's a problem. We know that something is happening. The next step is, how do we then go and figure out what the problem is and why it happens, right? So for that, I'm actually going to jump into Lightstep now. So as you can see here, I've jumped into Lightstep. And this is what we call our service directory in Lightstep. In this particular service directory, every single service that is reporting tracing data into Lightstep is listed on the left-hand side. For each of these services, we monitor all the endpoints of the services, and we mark those as key operations. And this is configurable to whatever you want, honestly. And so what we do is we'll monitor each of these endpoints for a 10-day period. Based on just the trace data, we will calculate their error rates, their throughputs, and their latency just automatically. And then what we will do is capture in the background tens of thousands of traces of individual requests that represent the entirety of your latency distribution. And the purpose for that is so that when you have a problem like this, right? So I am looking at this update inventory operation in my mobile device, in my iOS app, and I see that there is a spike, right? There's obviously this spike in latency, and I need to investigate what that problem is. So traditionally speaking, a lot of teams, DevOps teams, that we've talked to, without this type of a system, what they'll end up doing is they will say, okay, we have a problem. Let's pull all of the teams into a big war room and work on this. Let's dig through our log files. Let's, ask that person who's been around forever what they think the issue is, right? All of these are unfortunately kind of slow and not really scalable solutions. What you're trying to do when you see a problem here is you're trying to figure out what broke and why, right? I mean, obviously. And so with Lightstep, the way that we answer the why is we actually compare the regression against a known good baseline sometime prior to that. And we will say what changed in your system, which is a good approximation of why something broke, right? Obviously, usually things break when something changes. So looking at this, what I've simply done is I've simply clicked my mouse on that particular regression, and then this dialog pops up that says analyze the performance. And what I will do now is click the 1 hour prior. So I will compare that regression data set to the baseline, which is about an hour before that, where this problem did not occur. Okay. And what the system will automatically do is bring us to a interface that we call this kind of our RCA page, where it will automatically take a look at, in this case, about 1,200 traces in these two kind of 20-minute time periods, and they will analyze them in aggregate for you to help understand what's going on. So what we have here is information such as, what is the latency distribution between the baseline in blue and the regression in yellow? And obviously we see that there is a second mode of latency distribution that is introduced with this regression. Now, when we first identified this problem, what we said was, okay, this was experienced or noticed or alerted on from the iOS services update inventory operation, right? That's what we were originally looking at in Nobl9. But the issue is, just because you've identified or noticed an issue at a certain level of your stack, like the mobile device level, which generally tends to be at the top, that doesn't mean that's where the problem actually exists. The problem can theoretically exist anywhere downstream from there. So with Lightstep, what's actually happening is that we will automatically do that analysis for you. We can actually show you, because what we're doing is in analyzing in aggregate hundreds and thousands of traces and showing you what the behavior patterns, the code paths that are taken across all these traces, and the timing and the errors with all these traces, we would be able to show you something like the fact that this iOS update operation, inventory operation, actually, ends up calling an API gateway. The API gateway does some authentication calls as well as a backend service call. The authentication call then goes to an authentication service to do some authentication work. And then the call backend service call then ends up calling the inventory service to do some update inventory work, which includes some database updates and some cache writing, okay? And so as you can see by this very obvious big yellow circle, this write cache operation is the bottleneck, right? This yellow circle represents total latency contribution. Where is the time spent across all of these instances of requests that I'm investigating? And we can show you very obviously here now that the time was actually mostly spent in this write cache operation. So what does that mean, right? What this means then is I know now that this one call, this update inventory operation, which originated from my iOS device, actually hits 4 different services: the iOS service, the API gateway, the authentication service, and the inventory service, right? So I can now know which teams are affected potentially by this. And I can also now tell you that the culprit or the bottleneck is actually in the right cache operation. So I can now basically say we don't have to bother the authentication team because that's not where the problem is. We don't have to bother with the API gateway team nor the iOS team because that's not where the issue is. The issue is in the right cache operation. So this here is a relatively simple example. I only have 4 services in my environment. But if you can imagine it, with a lot of, at least some of our customers that can tend to have hundreds, if not thousands of services in their architecture, any given request that they make can potentially be hitting, tens, if not hundreds of services. Just trying to identify where the bottleneck is very, very difficult if you don't have this capability. Okay, so with that, I can, pretty confidently give you an answer to kind of what broke, right? Like this right cache in this inventory service. But the next question then is why, right? And the why is oftentimes translated to, what changed in my system. And as part of distributed tracing, the basic data set of distributed tracing is the ability to, excuse me, is the ability to actually attach any key value pair attribution to your operations, as well as attach log statements to your operations. And that's all just part of the basic instrumentation data set of the open source SDKs. And with that, what you're able to then to do is all that automatically gets sent to Lightstep as part of our analysis. And what we will do is to do things like, between these two, the baseline data set and the regression data set, is there any difference in their attribution, right? Or did any of the attributes change? So for example, we see here that there is a version ID 480 and 479. Neither of these existed in the baseline data set, but now they do exist in the regression data set. And obviously one of them, version 479, is much slower than 480, right? We see that there is this attribute called large batch, which is set to true, which does not exist in the baseline data set, but does exist in the regression data set. And so based on this data, we can pretty confidently surmise that this problem probably occurred during the deployment of a particular version, probably 479, probably 480, maybe like, a fixed version release or something like that. But 479 was where the regression was introduced. And perhaps one of the issues is that you're starting to write larger batches to your cache, and maybe that is suddenly hitting some kind of a limit. So at the end of the day, right? I mean, it's I think impossible for a system to say to you, this one thing is the problem, right? It's too difficult to actually know that. But it is actually quite reasonable for a system of like Lightstep to say to you, instead of the 50 different possibilities for this particular, problem, here are the 5 you should actually be investigating, right? And we are able to actually help kind of reduce that search scope and help you identify the problems faster. So what I've shown just now is how we look at attribution, but in addition, we can also look at log statements. So as I mentioned, log statements can be attached to the trace data, the trace operations. And if you attach log statements to the trace operations, what we will do is automatically suck those in. So for example, like oftentimes when you run into a problem, you will go and look at the log files, right, for that time period or for some requests in that time period. And the issue with that is you'll see an error, and it's kind of very human to assume that error is related to the problem, right? But with Lightstep, you can actually see if those errors existed in the baseline as well. So if you can actually see that this error that you think might be causing related to your problem also exists in the baseline, then you can actually kind of rule those errors out as red herrings, right? They're not actually related to the problem you're facing, or vice versa, right? If you see that this error did not exist in the baseline but does exist in the regression, now you can actually be much more confident to know that this is actually related to the problem that you're facing. So the whole idea that I've shown so far is we as Lightstep take this distributed tracing data set that's very powerful. And what we do is we capture all of them and we help you look at aggregate patterns of what is happening in your system so that when these problems occur, it is much easier, much faster for you to investigate and do this analysis. The way that we design the system is we want even your most junior engineers to be able to come and debug your systems, at least, the first 2 or 3 levels of debugging of your systems. Now, one of the things that I have not shown you is a trace, right? Everything that we've looked at so far is an aggregate view across all of the traces or a large data set of traces in your environment. What I can then do now, obviously, is we can dig into a trace, right? Here's now an example of one of the requests that we've analyzed. And this is the ability now to then take this analysis and follow that one individual request all the way from the mobile device, all the way through the backend services that it hits. And as you can see, each of these operations, which we call spans, have their own set of attribution and log events that are attached to them. So now you can dig through this to see any detailed information that you want. Now, just complete kind of like transparency here, right? The data set that we get this from, right? The individual trace data set that we get this from is from distributed tracing open telemetry data sources. And that open telemetry open source data source can be sent to any system to analyze. And so literally any system that that accepts this data source will be able to show you a request like this, the trace of an individual request. What Lightstep does that no one else does is to be able to actually take large representative pools of those requests and analyze them in aggregate for you to not only show you the behavior of an individual request, but to show you the behaviors and problems of a whole class of requests, okay? One of the things that we have added here at Lightstep is this idea of workflow links. And the reason we added this is because I recognize that we're not going to be the be all and end all and the only data source for all of your data, right? The only analysis tool for all of your data. So with Lightstep, let's say you have a log system and you're logging like an order ID or transaction ID so that you can query for those transactions in your log so you can kind of get an aggregate view of all the log statements for that transaction ID. All of that you can actually link to from Lightstep. We can set up these very dynamic workflow links that says anytime I see a transaction ID, which can be added as an attribute to your trace data, anytime I see that transaction ID show up, in my trace data, pop up a link to my log aggregation tool. And then add that ID to the URL search parameter. So I can, with one click now, go from Lightstep and this one trace to go to my logging system and see all of the logs in that system. And this can be used in any way, right? This can be used with the ability to go to Nobl9, with the ability to go to Jira, GitHub. It doesn't really matter. We can just create these very flexible links. So hopefully what I've shown you in the last kind of 20, 25 minutes or so is kind of how we take that data, the SLO violation, that monitoring that Nobl9 does. And when we know that there is a problem, how do we then go into Lightstep, which provided the source for that metric, for that SLI at least, how do we go into Lightstep to then debug that issue and try to find out what is going on and why the system broke? The other thing that I want to point out today is, as I mentioned, we as a data source are feeding these service level indicators into Nobl9 for the actual monitoring and the calculations of the SLOs and the alerting. So, which means that Lightstep obviously has the ability to create these types of SLIs. So with Lightstep, there's this idea called a stream, and this is much more for the monitoring of your distributed tracing data set. And with the particular streams, the way that we work is that we'll be able to actually take any condition in your system. So any service, operation, and metadata tag combination, and we can say, watch that. So you can, in this case, I've created a stream, because we were using it for the SLO. This one is just for the service and operation combination, but I can literally create one that is for this service, for this operation, for one single user. If you needed to say, Mike is the boss of company X, and I want to make sure his performance is always good. I mean, just as a example, we can actually configure that in Lightstep, right? So that we can watch that service, that operation for that one user. And as soon as I configure it, Lightstep will actually create this stream, which is this metric that you see here, for up to 2 years, that will monitor the error rates, the throughput, the latency from the P50 to your P99.999 if you want. And we will be able to monitor all of those, as well as provide example traces, which are these dots that you can click into and actually view traces. And these traces are actually representative of the entire latency spectrum. So the idea here then is you can set up Lightstep to monitor any condition you want in your system and create your service level indicators. Obviously, Lightstep as a platform has our own alerting capabilities. Our alerting capabilities is based along static threshold. It's obviously not as kind of as sophisticated as Nobl9's SLIs and SLO calculations. But obviously we built this into our system as well. But what you can then do is take these streams, like I've shown you at the beginning of this demo, and use them as data sources and to send into Nobl9 for the calculation and the monitoring of your actual SLOs. So you can do all of that within that system. Okay, so hopefully today I didn't want to take you through an entire walkthrough of all the bells and whistles of Lightstep. We also actually have the ability to monitor not just your distributed tracing data, but also analyze your metric data and actually tie that into your distributed tracing data set, so that when you have a CPU spike, we can actually tell you if it's actually how it's affecting your application performance or vice versa. We have the ability to actually ad hoc query your systems for the last hour, so you can query for any request, anything in your system, and understand what the service behaviors are like. But I don't really, I wanted to kind of keep this particular demonstration into areas that are somewhat pertinent to how we integrate with Nobl9. So if you are interested in all the other things that Lightstep does, obviously I'm happy to discuss this, and I'm happy to do further demos for you and your team. Again, my email is andrew@lightstep.com, and please feel free to reach out to me. But I just wanted to show you today how we work well with Nobl9, where they would do your monitoring and calculations of your SLOs, and we would help in terms of obviously creating the metric that they would monitor, but as well as how do we use the system to debug the problem when they do eventually occur, because everyone's going to have problems. So hopefully you guys have found that useful. Again, I wanted to give you just more of a short taste of this than a full drawn out demo. But if you have any questions, I'm happy to answer this. I hope you have questions. Unfortunately, I just kept talking for a long time. So, please feel free to just ask questions if that would work. Thank you.
Awesome. Thanks, Andrew, for that. That was a great overview of Lightstep. We at Nobl9 are super excited